Hello everyone, welcome to my channel. I hope everyone is doing well and you are able to hear me properly. Please reply in the chat if so. So we will be waiting for a few more people to join in, and then we are going to start today's session, which is going to be very interesting because we are doing something different, I believe, and a lot of this has to do with AI. Now, normally what we do in this channel is that we start coding and we write line by line, but now things are changing. So AI is taking over and now we need to use it as a tool. So we will be learning how to use AI as a tool to actually learn to program this drone. So we have a specific scenario. I will discuss in detail what that scenario is, and then we will try to solve that problem. Okay, so please let us know, where are you coming from? Where are you joining us from today? So we have a few hellos, and let's wait for a few more people to join in. Hello. Okay, if I push the mic in, hopefully it will sound a bit better. I believe somewhere here. Oh, let me sit up straight. Okay, so we have someone from Bangladesh. Okay, that's great. Well, today the chat is a bit slow. Normally we have lots of replies all at once. But today we have Salam from Tunisia, and we have the flag. Tunisian flag is red with white. Nice flag. Hello everyone. US, I believe it's Kentucky, Connecticut. Yeah, Connecticut. Sorry, my bad. Okay, so welcome, Illusion Technology. Welcome, Mahdi Zaid, EE Adventure, Hari Sankar R. Okay, so very diverse audience so far. I'm not sure how much delay are we getting on the stream, so hopefully it's not that big. Okay, so coming back to our problem, we are going to solve today something that is very familiar because we have done this before, but in actual drone with actual drone. So we had a similar situation where we had to find obstacles and go through them autonomously, and we did that using the Telo drone. If you have seen our courses, we actually taught how to do that using the Telo drone. But now the issue is that the Telo drone is discontinued and they are not manufacturing it anymore, and the ones that are already there, they are very hard to find. And secondly, a lot of companies, they don't want to share the control of their drone. They just want to give you as a ready-made product that you can use off the shelf, and you don't really program it because sometimes they are concerned with security, sometimes they are concerned with open source nature and closed source stuff, but mostly companies are giving it as a product rather than as an educational tool. So what we are trying to do is we are trying to bridge that gap. There's a lot of companies that are producing drones, but not a lot of companies that are producing drones that could be programmable. And very soon we will see lots of drones flying around everywhere. And and if you look at the recent what do you call the expo in China, they had a giant expo where almost 5,000 new UAVs were shown, and almost 800 companies were participating in this drone show. And they unveiled so many good robots and good drones, from agriculture to police to farming to household. So many applications were shown in those what do you call it, expo, that it's inevitable that eventually it is going to be in the market, it is going to be near you. You will be having deliveries with drones. There will be a lot of things that will be dependent on drones. But now the thing is that if you want to be ahead of the curve, if you want to learn, and I believe in universities and institutes, something like this should be available so that you can learn from school, from university, rather than just, YouTubing around. So, what we are trying to do is we are trying to create a software which will be easy for everyone to use, and then you will be able to go through different scenarios and real world scenarios. The problem with lots of drones is that they are expensive, and you cannot apply your techniques directly on the drone if it's, let's say, $1,000 or $5,000, and you're hoping that it will work, right? So what if it crashes? What if the battery dies out? You went too far. So there's a lot of issues when you are directly going and programming drones. Think of it like this. If you were to learn how to pilot, right? If you wanted to become a pilot, then you would not go directly fly a plane. You would first learn for a few hundred hours how exactly can you fly, and then you will go and try it on a real plane. And then companies and people who are actually building the planes, they will be more comfortable giving you the opportunity to actually fly, or what do you call, be a pilot. So the same thing goes with drones. Right now they are, okay, they are, the battery life is not that great, but eventually they will be good. And then there will be drones that are moving into rescue missions, that are moving into agricultural lands. So people would want good engineers who know how to program these, and not something that you will break right away testing your code. So that's the basic idea of what we are trying to achieve: creating scenarios that will be real world, and that will be fun as well. So a lot of this, even if I don't have to become a pilot, I actually enjoy writing the code, fixing some problem, and seeing the result, especially when it's with computer vision, because you see direct result of what did you actually do. So it is quite a lot of fun, and that is what we are going to do today. So Hari Sankar is from India. Welcome, Hari. Thank you, Murta. Always nice to join you live. Thank you very much. We have a regular joiner, Illucent Technology Solutions. And then we have, hey everyone, I want to start your drone classes, but it seems to Telo drones are not any more available. Any suggestions? Well, that's the suggestion, right? uh, we already have the same comment that these drones are not available anymore, and we need to do something to actually further our learning process and learn these new techniques. Okay, so now this is going to be very interesting. It is going to be hands-on, and we are going to start from scratch. So let's start. This is Pysimverse. By the way, Pysimverse is launching on 5th of August. This will be Tuesday, not this coming Tuesday, the one after this. So what exactly is Pysimverse? It's a simulator for drones. You will have multiple scenarios where you will be able to participate in challenges, competitions, and just for learning purposes as well, you will be able to learn through this simulator. Now, will it be free or will it be paid? some parts of it will be free. You will be able to run some of the scenarios completely free. You'll be able to download and run it. And then some part of it will be paid. So you will have competitions, you will have live sessions. So all of that will be under the paid umbrella. So if you are interested in that, this will be something of a subscription model. Now, the subscription model, I know it's a little bit tough for a lot of people. So what we have done is, if you join us or if you back us on Kickstarter, you will get a lifetime deal. And that is only because you will be helping us out to bring this to market. So if you join us in Kickstarter, if you back us, you will only have to pay once. And whatever new levels we bring in for the drones, you will get it for free. Whatever live sessions for life you will get for free, and whatever competitions you will get for free. So one-time payment, but after Kickstarter it will be monthly subscription. Some of it will be free, yes, but a lot of it will be paid, because we will have our developers, designers, and our marketing team working day and night, bringing new stuff for you, especially as the technology advances. We will have multiple drones, we will have multiple scenarios, and I'm very excited about the competitions, because we will bring in companies to sponsor different competitions worldwide for universities and schools and institutes, and hopefully it will be a lot of fun. Okay, now what are we doing today? So we have this Pysimverse simulator. The good thing about this is that we have designed it to be half the screen. So that is very useful, because you can simply drag it and make it bigger and smaller, and you can have the coding part on one side. So I can simply push it here, and then I have, what else do I have? I have this. I can put it on the other side, and I can simply code, and I can now increase or decrease the size based on if I wanted more screen area or less. So for example, right now we'll keep it less, because we'll be focusing on the code more rather than the actual result. Okay, so what I want to do is I want to use cursor, and using cursor I want to write the code to program this. Now how exactly can we do that? Okay, let's make it a little bit bigger. So right now this is just a simulation, right? Now what I can do is I can connect to this drone, and I can run it, and I can get its feed, like you do in Telodrone or some other drones, where you can simply connect it through Wi-Fi, and it connects the same way, and then you can get the feed out of it. So what we have done is we have created examples. So over here you will see we have these example basics, image capture, sort, YOLO. These are some of the, I would say, template codes that we have, so that we can use it in different scenarios, right? So here what we will do is, the first thing is that we will try to connect with it. So if you go to basics, this is how you connect. So you write from Pysimverse import drone, and then you connect to the drone, you create the object, you connect to the drone, and then you simply write takeoff, for example, move forward, rotate, and land, and that's it. Let's remove the rotate, and let's run this, and see if it will work. So if I increase the desktop audio, you will be able to hit. So there you go, it moves, it goes forward, and it lands. So we can click on reset, and then it will reset. Now what we want to do is, first of all, let me explain the overall concept. The overall concept is that we are going to fly the drone, and we are going to capture images. So that this is a hoop. Let's take it off and then not land. Okay, let's keep it in the air, and I will show you the hoop. There you go. So these are the hoops that we want to detect, right? Let me turn off the volume from here so that it's not annoying. Anyways, so we need to detect these hoops. Now what we can do is we can take the images of these hoops, and then we can train our own model, right? So using YOLO, MobileNet, SSD, whatever technique you want to use, you can use that. And then using that, we can detect those and then tell our drone to move based on that. So it is quite interesting how we can achieve this. So the basic idea, first of all, what we will do is we will write some code that we are able to move around and we are able to capture images so that we can store them in a folder so we can label them and train it, right? So let's go ahead and do that first. So in order to do that, we will go to cursor, okay, and here we have, let's say we will create a new folder here, and we are going to call this obstacle course, okay, and then we can right click it and create a new file, and we are going to write, let's say, main.py. Okay, so inside this main.py we are going to write our code. So we will give it the context that we are talking about main.py, and then we will give it some example codes. So let's try to make some sense out of this. What we'll do is we will say that I want you to capture images of the drone feed using keyboard. Okay, that's the main idea. The user should be able to move the drone using arrow keys, and when S button is clicked, it should save the image in a output folder. Okay, yeah, so that's the idea. So then we can give it reference. This is how you can capture images from the drone. And then do we need to give any other example? Okay, yeah, we do need to tell it how to move forward and backwards, right? So there are two ways you can move. One way is you can write, for example, drone dot move underscore forward, right? This is one of the ways. The other way, now this way is basically dependent on time, because you are giving it a distance, so based on time it is going to move, or based on an accelerometer or some other distance measurement sensor, it is going to move forward. But if you want to constantly give it speed and move it around, then you can use drone dot rc underscore control, and then you have the values, the forward, backwards, left, right, yaw movement, and all that, right? So that's the idea. So if we want to check that out, we can go back here and we can click on drone, and we can find rc underscore control. There you go. So send rc control, that's the function. And then this is how you can control the speed of the drone using RC control, right? So I think that should be enough. Let's hope for the best. Okay, do we have any questions? Can I do path planning in Pysimverse? Is it available or when? So path planning, of course, when you are working on drone deliveries, you will have to work with path planning with GPS control and all that. So yeah, definitely that will be included as well. Hello back, Shivam Singh. Welcome to our live session. Okay, so we have something. We have something. Let's check that out. So here we will have this folder obstacle main.py, and let's close everything. Let's skim through this. There's an output folder. It is checking if the path exists or not. It's initializing the drone. It's turning on the stream. It's giving it a default speed. Then you have left, right, forward, backward, up, down, yaw. Then it's giving us some prints. Image counter. Okay, it's also giving us a counter, which is good. Then it also showing us speed and giving us some information. And yeah, then we have the keys. It's using OpenCV to actually do that with the keys. And it's using AW and so on, AWSD rather than arrow keys. So it is rotating right. Okay, so you have these different keys. Okay, so let's run it and see if it will work or do something. How do you take off? Okay, there you go. We have the stream, and let's see. Arrow keys move S for save, Q for quit. Actually, did not use arrow keys at all. It is using, oh, it is using 82. So that's arrow up key, yeah. Well, that could work. What about the takeoff? How do we take off? Does it mention here how do you take off? Let me find. Take. No, it's not taking off at all. So let's go back, and we are going to tell cursor add a button for take off and land as well. It's taking a while. Okay, there you go. T for takeoff, L for land, and then all of that. Okay, that's good. If you go back and if we search that again, takeoff, there you go. So T is for takeoff. So let's run it and we'll press T. T, nothing happens. Why are we not able to take off? Takeoff is T. Is it supposed to be? No. Okay, AI is failing us. Oh, something happened. Okay. Okay. So I understand what's going on. It's not actually taking off. Where is the take off command? Find take off. Okay, what we can do is we can manually write it down here because I think the AI is not getting it at all. So what we can do is we can go to basics, and this is what we need. Drone.takeoff, that's it. So we can go back to our main, and once the drone connects and stream is on, we can simply tell it to take off. So hopefully that will fix the issue. There you go. So now it's taken off, and what we can do is we can open this up and then we can move around. Okay, it's going up and it's landing. So L is for landing, T is for closing. Let's try that again. So what other keys we have W and X, yaw is A and D. That's too much yaw. It's flying. So let's look at the yaw. Yaw find minus speed. Oh, no, 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 no. So what we can do is we can put here like 5. That's too high. Rotating left and right. And there you go. Even now, still a lot. So we can put, let's say 1 and 1. So as you can see, it's so simple to actually test. There you go. So now our speed is much better because we don't want flying in. Now, how to move forward? Let's see. Okay, let's ask it to, I want to move forward using the W key and S for backwards. For saving, just use, let's say Z. I believe that was conflicting, that's why it did not do that. So let's run it and see if it works. No, did not work still. So Z or Z is for saving. Oh, it's still working on it. That's why. Okay, let's accept that. And okay, there's a conflict with the Q as well. Now it's trying to change that. Okay, the model did not make any changes to the file. Sometimes the AI goes so far away, it's hard to bring it back. Forward, backwards, left, right, arrow keys up and down. Okay, let's try that. There you go. So now W is back and W is forward and S, and then you are going left and right. It's a bit slow. And then we have J. Now J is for yaw, and then we have L. So what we can do is we can press Z and that should save. So there you go. So it has saved one image. Then if we move around and we rotate, oh, it landed. I pressed the L button. That's not good. Anyways, but the image is saved, right? So we don't need to worry about that. So the image will be saved because here, if you go to obstacle output, oh, we have a lot of images saved, maybe from the previous runs. There you go. So here you can see we have all these images saved. And the idea now is simply that you move around and you collect these images. Now, once you have these images, what you can do is you can label them. So if you haven't seen our object detection course, let me show you. So in object detection, all you have to do is you have to label. If you are doing it manually, you have to label, you have to put a bounding box around this, and you have to say, okay, this is, let's say, what do you call, our hoop, and then this is another hoop. So you basically mark these images and then you train it using whatever technique you want. So mostly nowadays we use YOLO, and that's how we can basically collect our data. So that's the first part of collecting data. So what we can do is we can change the name of this to let's double click, right click, and collecting underscore data. So this is for collecting the data, and once the data is collected, then we will have a output file once we train it. So once we train it, we will get something like this, model.pt. So let's copy that. So this is a model.pt that we have already trained on these, what do you call, hoops. So now what we can do is we can use this model to actually run our code and see if it detects these images, these hoops. So we'll go back to cursor and we will open up a new chart, and here we are going to write this is collection underscore data, and then we will create a new file, and what should we call it? Let's call it hoop detection. Oh, I forgot to write .py. Okay, now inside this hoop detection, we are going to say that we have the example of YOLO and we have the example of image capture, right? Now we need to merge these two using the image capture technique. Get the image from the drone and apply YOLO on it. Use the model.pt, or actually we can just drag it. Use the model.pt. What happened? Okay, it's not coming in for some reason. Anyways, so we can simply write it model underscore .pt instead of the default YOLO. Okay, I think that should be good enough. File is too large. Oh, that's why it was not detecting it. Anyways, so hoop detection, let's see what do we get. Okay, so again, now it is going to land and take off manually. So later on we can change that, but for now, let's just run it and see if it will work. It should take off, but I think it will not. Yeah, okay, it is detecting. There you go. So we have the detections, hoop, but it's not taking off. I for some reason it doesn't like to take off. So drone dot take off, and we can give a little bit of delay, but I think it should work. Let's see what happens. There you go. That looks nice. Okay, so that's the basic idea. Now we are detecting the hoops, and this is based on the training method that I mentioned, that you can basically collect all the images, you can label them, and then you can create a file out of it. And all of that we have explained in our free course, object detection. Just go on YouTube and write object detection Murtaza's workshop, and you will get it for sure. And we have explained everything, how to train it, how to custom train a model with your own images, and so on. Okay, now let's go for the fun part. We already have the working model, we have the detections, and now we need to make it autonomous. Right now it's just detecting and doing nothing, right? So we need to make it autonomous. We need to tell it to move forward, and then probably land as well. So we have this edge over here. Well, this is the helipad, or where you have to land. So that's the basic idea. So let's go ahead and do that. So let's move on and let's create a new file, and we will call it, what should we call it? Let's call it um, autonomous, if I can spell it right, autonomous hoop uh, uh, course collection data hoop detection autonomous hoop course. There you go. Okay, so now in this, what we will do is we will say that let's continue with this because it knows what we have done before. In this new file, make the drone autonomous so that it detects the hoop. It detects the largest hoop and moves towards it. Now we will constrain some things. The speed will always be constant. Let's say 50, and we will use yaw to move the drone. So apply PID on yaw. So PID, I believe a lot of you already know what PID is. It's a control method where you have two values that have no relationship between them, and then you try to create a relationship between them, because F equals MA. So F and A, they have a relationship, and F and M have a relationship. But then if two things, they are related to each other but they don't have an equation, what do you do? So you do PID, or you apply some sort of control. One of the most common ones is bang bang, where you just move around left and right until you go through. But then a PID is a renowned method that is very useful. Okay, so it is saying that it has done something. Autonomous hoop course. And then, oh, it has created a class for PID controller. That is some heavy stuff. Okay, then we have autonomous hoop course. Oh, it has also created a class for that. It's making it complicated for no reason. Find largest hoop. Okay, calculate your control. Okay, and there you go. Now, in terms of PID, it has three values that you have to tune. So let's see, where did they call this class? Probably that is where they mentioned these. Yeah. So yeah, the starting values are not so bad. What I like to do is I like to start from 0 and 0 and only run with KP. Once you have the whole thing running with KP, then to smooth it out, you can use KI and KD. So, well, that's my method. I mean, I could be wrong. There you go. Something is happening. It's flying. It's autonomous. Oh, what happened there? No hoop detected. It actually flew too fast, and then no hoop detected. Now imagine if you were to do this on a real drone and this were to happen. That would be bad. That would be really bad. And probably it's because of this. Let's put it at 0.01. Okay, and yaw, let me check what value to give yaw. Your output, oh, clamp the values from minus 50 to 50. See, that's the problem. So you need to clamp it way lower than this. So maybe 3 and 3. Because it's yaw, it's turning, so it will be very fast. So let's run that. Okay. I feel like it's moving in the wrong direction or it's moving too fast. We'll have to figure that out. um, so the image center is 320. I believe that is correct. And then the area of the largest hoop detected. That seems fine as well. Let's put it at 0.01 and let's try that. So we can slow things down. If it doesn't work, we can increase the value. It's easier to do that than the other way around. There you go. So now clearly we can see it is moving in the wrong direction. So the values we need to what do you call, inverse. So your output here is the clamp, and then we do this, we do the opposite of this, minus hoop center X, and hopefully this will make it move. There you go. It's moving. It seems like it's going to hit. And there you go. It hit. If it hit fast, it will actually drop down. But because it's very slow, and actually Tello does this too. This is actually very real. Anyways, so we need to start from the top. When we take off, it should be a little bit higher. So let's find out where is the takeoff. Drawn.takeoff. And what we can do is we can give in a value here. I believe takeoff height. Yeah. So takeoff heights, let's put it at, let's write it here. Takeoff height. I believe 200. Or it wasn't that far though. Maybe 150 will do. Oh. Yeah, no, I don't want to see the result of that. 150 maybe. Let's try that out. That looks promising. There you go. Now you could add the PID on Y as well, right? And there you go. So it actually solved one hoop. Now it's going for the second one. And oh, excellent. It detected both the hoops, and now it looks really good. What do you guys think of this? I mean, how long did we code this? What's the time? Probably less than half an hour because I've been explaining a lot. So like less than half an hour we are able to do this. I mean, that is amazing, right? It's impressive to me. If I were to do this on a real drone, it will take a lot more. Yeah, that's for sure. Anyways, actually there's a big delay, and that is really annoying. Anyways, moving on. What else can we do? We can count how many hoops have we crossed, and then we can try to land. So that's the landing area, and we can ask cursor to do that for us. So far so good. Now I want you to count the number. No, I think it's already counting, right? I'm not sure. I want you to count the number of drones, number of hoops, my bad. Number of hoops that the drone passes. If the number is 2, then it should land. Yeah, I think that's enough. So we have hoops passed, and then we have maximum hoop passing threshold. Priya is saying, doing wonderful projects. Keep it up, bro. Thank you very much. Wish Zach Bros Mysterious World says, hi, sir. Hello. And KWS says, great job. Sample code, please. Sure. I'll share this somewhere. And once we launch, we are going to share a lot of stuff related to Pysimverse as well. Okay, so moving back to our project, I believe it will show us a count now. Let's see. There you go, 0 out of 2. And there we have the first one. And then that's the second one. It's showing the red dot. There you go. It's going smooth. But why didn't it show the hoop count? What happened there? Okay, something is up. We need to fix that because it passed 2 hoops, but it did not detect 2. It passed 2 hoops, but it detected only 1. Check the issue. The first hoop was not detected. I believe that was the case, right? So it's saying that we are adding a more robust detection method that considers the position of the hoop in the image frame. Okay, that's a lot of wipe coding though. Usually what I do is I like to read out and try to skim through the code to at least understand what the logic is behind all of this. Okay, so it is creating a function to check the passes. Now, what I think we can do is we can simply give it we can find the area of the hoop, and if it's too big, it means it is about to pass, and then we can detect it as passed. Not sure if that is what the AI did. Let's run it again and see if it will be better than before. So this part here is the simulator telling us how many hoops you have passed. But here we are the ones detecting how many hoops do we have passed. So here it is assuming that it has passed 1, and it is saying it has passed the second one as well. Okay, that's bad. That's not good. Okay, let me give it a hint. The hoop detection method is still not good. It detects too early. Wait for uh, wait for the area of the hoop to get at least 80% of the screen size to detect as hoop counted, hoop crossed, and also don't count the hoops or apply the PID when the hoop is being crossed, i.e. uh, go straight for a few seconds and then start the process again. I hope that makes sense. And yeah, of course, the PID is interfering with the detections as well, and that could be the cause of this. So it's trying to change it. But as you can see how simple this is to get things up and running and fix them and run it again, and you can reset it. And the good thing is that you'll also have a percentage of battery here. So if the drone is not able to do it, it will die out. But of course you will not have to pay for anything because the propellers will be safe and the drone will be safe too. Okay, it has applied the logic. Let's rerun it. There you go, it's running. And there we have it. The hoop count is 0 and it detected the hoop count. And then oh, what oh, it's going straight for way too long. But it seems to, oh, it's going to collide. I think the time is the issue. So how many seconds did they put? They put, okay, can't seem to find the time. Remaining time, crossing duration. That's the, I believe that's the value. Seconds to go straight after crossing. Let's, I think it went a lot more than that. Let's put 1. Let's see what happens. I think it went like 4 or 5 seconds. Oh wow, it goes for like 8 seconds. Probably something wrong with the code. And it goes and hits again. Mission completed, landing. Don't land. Okay, something to do with the time. So weird. Let's go back and check that time. Yeah, here we have the remaining time minus cross duration time minus start time. Like the AI could have just given a little bit of delay, and yeah, that's pretty much it. But okay, okay, we can ask the AI. Even though the delay set is 1 second after the hoop, it still moves forward for about 8 seconds. So hopefully we can find a solution for that. Okay, so it's saying that there might be an issue with the state management, and it is trying to fix it. Excuse me. Pardon for the interruption, but Slam is being implemented, right? I wouldn't say this is exactly Slam. Uh, it's more like PID control. Okay. Okay, let's run it. Hopefully this will be better this time. Oh yeah, it looks good. There you go. I have high hopes now. And we are moving in. We are moving in. And the mission is completed. Oh, come on. Okay, so I guess the area threshold is a little too early. So what's the threshold of the area? It's 0.8. Let's make it 0.9. I believe a lot of you have some great ideas on how to better approach this problem, but this is what I have so far. And it's not the best, but it will get the thing done, hopefully. Okay, so it's moving forward, moving forward. It's about to get there. Ah, come on. I think 1 second is not enough. Let's put it at 3 seconds. Where is that? There you go. Duration. Let's put it at 3. Now I believe it will work. The 100th time is the charm. Okay, moving in, moving in. Going straight. There you go. Looks good. Looks promising. Moving forward. Moving forward. Detected. Mission complete. Ah, come on. Why does it detect so early? Screen area threshold. Oh, that's the one that we need to change. 0.9. So that is the one that we need to change. Hopefully, hopefully. Fingers crossed. Okay, the first one now, pretty much we do it every time and it works fine. And now it didn't. Okay, so let's make it 8.5. You know, that's how you jinx. I said we get it right every time for the first one, and straight away we got it wrong. And this time around we got it. Yes. One hoop detected. Come on, come on. Move it in. The PID is very good, even though it's just KP. Look at the dot. I mean, it's very good. Ooh, almost, almost. We just need a few more seconds to move forward, and I believe we'll be there. Cross duration, let's make it 5 seconds. So for 5 seconds, nothing is going to happen. It will stop processing and it will just move forward. Okay, let's do it again. The first one is detected. That's good. And now it turns. Now it turns. Mission completed. Moving forward. Ah, you know what I think? It's not moving forward after the second obstacle. Okay, let me just write it here that when the second obstacle is detected. It does not move forward for the given time, i.e. the delay. It should be for landing. I guess that's the issue. Okay, let's see what it does. I see the issue when blah blah blah, hoops pass is greater equals to hoops and lands before the crossing delay. Yeah, if this works, we can even reduce the delay a little bit and it should work fine. Okay. Now I'm getting tired. I have been working physically on this project. By the way, yeah, uh, I didn't mention in my this channel, I didn't mention that I actually created a new channel where I am converting a buggy ATV all-terrain vehicle to go-kart. So you can simply go to YouTube and write the kind of car guy and you will see my channel. I started this month and right now I'm converting, but it's in my mother tongue, which is Urdu. So if you don't understand, maybe you can use subtitles, right? But it's very interesting. Today I got the engine running. It's a 200cc engine and it has about 6.5 horsepower. So I'm waiting for the clutch to get in and then it's almost 70% complete. So hopefully very, very soon we will have it up and running. Anyways, moving back, where is it? Where is it? Let's run it again and see what happens. Okay, so looks promising. Turns, goes forward. Yeah. Oh, 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 oh. Ah. Ooh, we just missed it. Task accomplished. Yeah. 34 seconds. Yeah, finally. It went for a little too far, I would say. Maybe 3 seconds, and it will, I believe, directly land on the helipad. But yeah, that's how you can solve this problem. Uh, you can see it's a lot of fun, right? So you test different things, and the weird part for me is not tuning PID. It's working by default. I don't know how. Like I have spent so many hours tuning PIDs, but for now it just works, right? I just randomly gave numbers and it worked, you know. And there you go. That was good. That was good. It didn't show up the task accomplished, but yeah, we are working on that right now. Right now, it's a product under development, so it's not completed yet. Anyways, so regarding the product, again, it will be available on Kickstarter. I hope you will join in. And the idea is that we will have a lot of live sessions like this. We will have tutorials, we will have competitions. One of my favorite ones is the line following, where you will have a track and then you will have to train your drone. You have to use PID, whatever you want to use, to actually follow the line the fastest way possible. And then there will be a leaderboard in which whoever goes the fastest will be at the top, and you can see it live, and you can compete, and then there will be sponsors and gifts and a lot of other stuff. And by the way, the first 2 or 3 days, I'll have to check with the marketing team. The first 2 or 3 days will be early bird, and it will be the lowest price, and it will be lifetime subscription. So after Kickstarter, it will be a subscription model. So you will have to pay a monthly fees to use this. But if you go through Kickstarter, only for the Kickstarter now, you will get it for lifetime. And we will be upgrading so many levels because we have a complete team of developers, designers that are building different levels of the same tasks as well. So we have agricultural drones, we have surveillance drones, we have traffic drones, indoor drones, and the best part, we have multiple drones. So you will be able to create drone shows. One of our tasks or scenes is that you give in an image, it will convert it into grayscale, and then that grayscale image will be converted into pixels. And those pixels will be, one pixel will be a drone. So each drone will be basically a pixel in the sky. And it's very interesting. You can use OpenCV to actually run that. So that is something I'm very looking forward to because we are very excited. It's almost been 1 year since we have been developing this, and now it's almost there, almost there. 5th August is the date. Today is 26th, so only a few days left. 5th August, that's Tuesday, we are going to launch on Kickstarter, and you will be getting beta access, you will be getting tutorials, live sessions, and all the new levels completely for free. No, not for free. If you if you get the lifetime, then from that there onwards you will get it completely for free. Okay. So yeah, that's the basic idea. I hope you have enjoyed this tutorial. I hope you have learned something new. It was fun. It was a small project. It was fun to play around with this. But of course, this is just the beginning. This is just the start. We will have a lot more complicated examples that we will be having in competitions and in other places as well, like these live sessions. So hopefully you will join us, and I will you can simply Google Pysimverse, and we already have a good ranking on Google because it's a unique name, I guess. We are developing the website. Don't visit the website, it's very bad right now. So we are developing the website right now. Our focus is not on the website, that's why it looks so bad, but our focus is on the Kickstarter, so we can get some funding that we need so that we can bring it to market. So this is it for today. I hope you have learned something new. And are there any questions? Which simulation APK are you using? It's Pysimverse. Can be used to train real drone. Yes, of course. So we are using physics engines to actually replicate real world examples. So what behavior you see of the drone here, you will see for the real drone as well. So let me share the link of the Kickstarter. Somebody has asked for the Kickstarter link as well. So Abdullah Jat is sending us some hearts. Thank you for that. So if anyone has any question, I think there's a lot of delay in this live stream. So what I say gets conveyed like after 10 minutes. Anyways, so this is it for today. I hope you have learned something new. I hope this was exciting. I hope you will join me again for this. Now, if you are not able to support Pysimverse by backing it, no problem. Sorry for that. I'm a little bit sick. No problem. If you are not able to support, that's okay. Not everyone can pay for the premium service. You can still enjoy the free service. But I would request that you share the project with your friends and others, so that you can spread out the word and help us get the funding so that we can get the snowball rolling. So this is it for today, and I will see you in the next one.